Sure. So an overflow or an underflow is basically an example of a computer program getting data outside of the bounds that it expects. You probably know that all numbers in a computer program are just binary, zeros and ones, switches that are on and off. So let's create a binary number. You start with 0, that means 0. Then you add 1 to it, that means 1. Then you add another 1 to it, but you can only have zeros and ones, so that 1 turns into a 0, and then we create another 1 next to it, 1, 0, that means 2. 1, 1 means 3. You add another 1 to it, but there's nowhere for that 1 to go, so once again we do the same thing. The first place becomes a 0, the second place becomes a 0, and we put a 1 in front of it. 1, 0, 0. That's 4. So on, so forth, so on, so forth. Now, numbers, when stored in programs, do not have infinite space. So for example, the highest number that you could represent in a byte is 255. That's 111111. 8 switches, 1 byte of data. If you were to add one more 1 to that 255, you would overflow it. You can't make that number go bigger, and so the computer's going to try to do what it usually does, make everything else a 0 and put a 1 in front of it. But that 1 is going to exist in some other data container, somewhere where it's not supposed to be. And that way you could get programs to do stuff that normally they wouldn't do. Now, 255 is the maximum number that you can have in a byte if you don't have a sign on it, as in it cannot do negative numbers. If you want it to do negative numbers, you basically have to cut it in half, because one of those zeros and ones has to be able to represent positive or negative. In which case, the maximum value of a signed byte is 127. So if you get up to 127, and once again, you try to add one more, there isn't enough space. So the computer does what it does before, changes everything to 0, and then puts a 1 in the last space. But that space is used for determining whether it's positive or negative. So by adding one more number, you actually end up with a very low negative number instead. That is an integer overflow. Similarly, if you try to subtract 1 from the lowest number, you get a very high number. So that's what people were saying in reference to negative Kelvin temperatures. It's a little bit like an underflow or overflow problem in programming, in that when you get to negative kelvins, you're actually getting a very hot thing. It doesn't exactly work like that, it's just sort of like that, but it's a neat thing to think about.